Okay, so today we're going to start working with your workbook 14. We're going to be working specifically with pages 1, page 2, page 3, 4, um, and that is all for lesson 1. And then we're going to jump on page 22 and page 23 to do some practice. Okay, so if you want to follow along the notes, if you don't have your workbook, I highly recommend you print page 1 through 4 and then page 22 and 23. I will solve page 1 and 4, and you have to do on your own page 3, 22, and 23. So, workbook 14 talks about the definition of congruence and similarity. So, we're going to see what these two definitions are. We're going to see when or how we can use different transformations, and then when we're gonna create figures that are congruent and figures are similar. Now today we're gonna be working on lesson 1, and the goals of today's class is that I want you to be able to define congruence at the end of this lesson. You're gonna apply properties of translations, rotations, and reflections. Notice that we're using all of them at the same time to show that figures are congruent, and then we're gonna explore properties of congruent figures. This is extremely easy. We already know how to do translations, rotations, and reflections, and we're adding a definition into the lesson. So over here, let's start with a warm-up. Usually you do the warm-up on your own. So if you want to stop the video and try for 5 minutes to do the problem, go ahead. It says that we need to write a sequence of steps. So we need to write and describe how each figure, the shaded one, could be mapped. So what are the series of transformations that can make me get this image from this image, okay? It says include notations or diagrams to support your statements, and then there's some sentence frames at the bottom if you want to help yourself. So the first thing that I'm going to have in here is I noticed that this figure and this figure seem to be the opposite of each other, so like a mirror. So that tells me that somehow there is a reflection in here. So I'm going to label these M, and I'm going to say that this figure, it's being reflected through line M. And when I reflect this line, I'm supposed to be getting a figure like this. Now the goal is that you need to do a series of transformations that this figure becomes this figure. And if you notice, still not the same figure. The blue one that I have in here, it's in a different section. So what else can I do after a reflection? I need to move this down from here till here. And the way I say that is not move down, we say that there's also a translation and units down. Okay? Now, this one is a little bit, I would say, easy because there's no numbers, there's no units, so we cannot tell exactly what's happening. It has to be very wide. Now, for example, number 2, it is a little bit more challenging because now we have units. Now, the first thing that I notice is that I have a figure that is like a letter A, and I have like a rotated A. So that means that somehow I took this A and I rotated this way, or I rotated the A this way. So I'm just going to say that if I take this as my center of rotation, and that's going to be the point 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Again, there's multiple ways to solve this. This is the way I see this transformation. I'm going to say that figure, sorry, I need to try to, see that's why it's important to read the instructions. I need to map this into this. Okay, so from the shaded A to the non-shaded A. So my center of rotation this time is going to be the point 3, 3. So with center of rotation 3, 3, I'm gonna do a, if I notice here, it's pretty obvious that this is a 90-degree rotation. Okay, so I'm flipping this 90 degrees. So I'm going to have a 90 degrees rotation counterclockwise. Okay? When I do that, my goal is that I'm going to get a figure like this. But that's still not the same, because I need to move this A to this section in here. So what I'm going to do is that I need to make this point in here. That means that I have to move 1 unit up, and then I have to move 1, 2, 3, 4, 5 units right. You can write this anyway. I'm trying to be very simple. If you want to be very fancy and say that I'm moving x plus 5 and then y plus 1, and then you want to write the transformation this way, go ahead. I'm just trying to make it really easy. When I do this and I move this figure that way, now this figure will be here and it's overlapping, which means that I did my transformation correctly. Okay, so that's it for the warm-up. Okay, so let's work with page 2. So there's different transformations in here, and what it says is that I need to try to do a series of transformations. So figure 1a becomes figure 1b, figure 2a becomes 2b, 3a becomes 3b, and then how 3b could become 3a. Okay, so I'm going to be solving all of this and helping you out how to identify multiple transformations. And after I'm done, I'm going to stop the video, and on your own time, like this is I don't like this figure because it is it is a different figure because you have a different shape. So for the rotation is difficult. This one is pretty obvious that is what's happening here, like a reflection, and it's been moved. This is a translation. You're moving to different directions. So the interesting thing in here is that you need to write 2 different strategies. So for example, here I can move up and then move right, or I can move right and then I can move up. So that's how you have to write 2 different ways of doing these transformations. This is the picture, or this is the work that I need you to send me one of them. Page 3, problems 1 and 2. I don't need problem 3. So let me help you out a little bit with these multiple transformations. We're going to see the formal definition of what it means when 2 figures are congruent, and then how do you know the figures and images are congruent. So we're going to go there. So let's start here. Well, the first one, I'm just going to take this shape. Okay. And the first thing that I'm going to do is that I'm going to rewrite that on my top problem in here. So if I look correctly, this is over here. Here you go. So I need to try to write, how can I make this shape go to this place in here? Notice that the figures are the same. Notice that the vertical lines and the vertical lines are the same. So this line and this line are both verticals. That means that there's no rotation. The image is not flipped, so there's no reflection. So what it seems to be happening in here is just a translation. So how can I make this point going from here till here? This is your translation, your vector. So let me change a different color. What we're doing here is that we're moving horizontally 1, 2, 3, 4. So we're moving 4 units to the right. It is positive when you move to the right, and because this is horizontal, we're talking about x. Then we're going to move 1, 2, 3, 4 units down. That means down negative. And if it is a vertical movement, we're talking about y. So my strategy, or the steps, if you want to write them in sentences, that's okay. You could say translate figure 4 units right. I'm just going to say that I have the coordinates x, y, and then they are changing to x plus 4, y minus 4. And that's it. Let's see what's going to happen if I want to move this shape. I'm going to now solve 1b. Okay, your figure is in here. What happens if I need to go from this figure to this figure? Now notice that it's almost the same thing, but we're moving the opposite direction. So if I need to reach from this point to this point, I need to move 1, 2, 3, 4 units to the left. Moving left is a negative movement. Left is a horizontal movement, so that corresponds to x. And then if I'm here and I need to reach this point, I'm gonna go 1, 2, 3, 4 units up. Because it is vertical will be y. You're going up is a positive movement, so y plus 4. So notice that these two movements were almost the same, but the opposite signs, or adding and subtracting for your x and y. Let's go to number 2. And again, I'm just going to take this picture. I need to zoom in because this is really difficult. So let me just take this picture in here. It will be 1, 2, 3, and 4. Okay, and I notice that this corner, it's at the point -1, +2. That's how I'm going to locate my point. -1, +2. This point was in -1, +2. There. So first thing that I'm going to do is compare these two figures. Notice that they are the same figure. That means that there's no reflection or rotation. That means that what happened in here, again, it's only a transformation. So let's see, what can I do? So this point that I have in here, now it's this point that I have in here. This is my translation. So let's see how many units I have to move to the right. 1, 2, and 3. So we're moving 3 units to the right. That's a +3. How many units I'm moving vertically? 1, 2, 3, 4, 5. I'm going up, so that's a positive. Y plus 5. I would say that my steps are taking x and y and adding 3 in x. That means moving right, and adding 5 in y, which is moving up. Again, if you don't want to write it in a fancy way, you can just like write in sentences. Translate the figure 3 units right and 5 units up. That's it. So again, I'm going to take this figure in here. And I know I have to go, this point will be the point -1, -1. So this point is moving here. The movement is going to be the opposite. I'm moving left and down. So x comma y is going to be x minus 3, y minus 5. Okay, pretty easy. It is the same movement. So I'm interested in this one, because if you see now, the shapes do have different forms. So first thing that I think, if it is a reflection, my shape should look like this, which is different to the result. If I do a reflection across the x-axis, I'm gonna get something like this, which is not what I have in here. So the figure is obviously moved, but it's also being rotated. So I'm gonna take this figure here, and again, we use the center of rotation. Okay, let me see a point that I can take. Okay, the point -3, +1. Here you go. Okay, let me compare. Yeah, I copied the figure correctly. So let's see. What I need to do in here then is rotate this figure. And I'm gonna use the arms that I explained to you last video. So if this is here 2 units to the right and I rotate this 90 degrees, this is gonna be 2 units up. So my new point is gonna be here. I do the same with the other point. I'm gonna go 4, 2. So I'm gonna go 4, 2 in the opposite direction. I'm rotating everything 90 degrees. And then I have 2 and a little bit more, like 4 and something else. So 2 and 4 and something else. Here you go. I didn't measure something. 4 and 2, 4 and 2. This is 2, and then 3, 4, and a little bit more. So 1, 2, 1, 2, 3, 4, and a little bit more. Okay, here I messed up. Let's fix this one. Should be somewhere over here. Here you go. Okay. Now if you compare these orangey figure that I got in here, I'm gonna erase my lines. Okay. They look almost the same. The only thing is that this figure needs to be translated 1, 2, 1 down. Okay, so we need to do also a translation, and we're going to take this figure and we're going to move it 2 units to the right, 1 unit down. Okay, so let's write down what we did. First, we rotated this figure 90 degrees counterclockwise, and then we translated the figure. So let's see. We have a center of rotation. It's gonna be the origin. I'm gonna have a 90 degrees counterclockwise rotation, and then I'm gonna have a translation x plus 2, y minus 1. Here you go. This is pretty easy if you had patty paper. So if you have some kind of like transparent paper, patty paper or something, and you want to place it on top of the figures and play with the rotations, go ahead. That's usually how I explain it in class. And it makes a little bit more sense, and rotations are a little bit more easier that way. Let's do now figure 3B. Again, what I'm going to do here is I'm going to trace the figure. Okay, again, it's not perfect. Should be the same, because the point is just to prove that they are congruent, which means the figures have the same characteristics, and I'm not doing a good job on that. Is it in here? Yeah, perfect. So now we need to take this figure in here, and we need to rotate it that way so we can get that figure. So let's do that. I'm gonna take this point first, and if I try to create my little arm, I'm gonna go 3 units to the left, 1 unit up. So that's gonna be 3 units up, 1 to the right. This is gonna be my new point. Let's change the next one. Let's do this point now. I'm gonna go 3 units up, so I'm gonna go 3 units right, and it's a little bit like here. Okay, and then the last one, I'm gonna take this in here, and I'm gonna go 2 right, 1 up. That means that if I'm rotating, I'm gonna go 2 down, 1 left. That's gonna be my next point. See how I'm rotating these 90 degrees? I'm connecting these lines in these points. Okay, And then what else do I have to do to be able to have the same shape? Both of them overlapping. I need to take this point, move it here. Let me use this point, which is I think better. I'm moving 1 unit to the right, which means x plus 1. And then I'm moving 2 units up. And notice how it is the opposite of what we wrote for the other one. So let's say I had the figure this way. I rotated clockwise. So clockwise rotation 90 degrees with a center of rotation at 0, 0, which is always going to be 0, 0. And then we're going to have a translation that maps the figure this way. And that's it. Okay? That's what we have in here. So notice that we're not doing only one transformation. You need to show that you're mastering all transformations at the same time. Nothing different in this case. We didn't have any reflections, but we had a lot of translations and one rotation. Let's go now to the bottom section, and let's read what it says in here. Two figures in the plane are congruent if the second can be obtained from the first by a sequence of translations, rotations, and reflections. So, if you can take from one piece and then from that figure you can translate the figure, reflect the figure, and then rotate the figure, then these figures are congruent to the original one by definition. Okay? So here it says, well, how do you know that the figures and images in the talking transformations activity? That's what we just did. Are congruent. So we need to say something like, let's see if I can modify this. Here you go. Okay. Didn't work. Now you wanna. Okay, I'll move it later. So we'll say the figures are congruent because they can be obtained by doing translations and rotations. There's no reflection, so I'm not gonna say it. Okay, and remember we kind of mentioned this before. Well, we said that a figure is, well, stay there. It's the two figures are congruent, and we barely talk about it, but we mentioned that they were congruent, and it was on your vocabulary. So we do say they are congruent when two figures can be obtained through a series of translations, rotations, and reflections, okay? Because we're not modifying the angles, we're not modifying the length, we're just taking the figure and we're keeping it the same. That's why these three transformations are called rigid transformations, because what they produce is the same figure. Your result is going to be a rigid. If you have a triangle, there's no way that by moving the triangle it's going to become a square or it's going to become a big triangle. It makes no sense. You're just moving, reflecting, or rotating a figure. So imagine that you are looking at a mirror, and then you see yourself, but you are 5 feet shorter. That wouldn't be a perfect reflection. Okay, there's something else going on in there. That's going to be our next lesson next week. Now, for now, what I need you to do is pause the video. I'm sorry, don't pause the video. I'm going to stop the video. And I will want you to work on page 3. And I want you to do problems 1 and 2. Okay? So how can you take this figure here? And how can you take this figure here? Okay?